Hadirnya UT memastikan bahwa setiap warga bangsa berhak atas pendidikan tinggi di bawah kekuatan hukum tanpa adanya perbedaan. Lebih dari 2 juta lulusan berhasil menyelesaikan studi di UT. Kami bangga, sudah 4 dasawarsa UT hadirkan pendidikan berkualitas tanpa batas.
UT selalu berfokus ke masa depan dengan tetap berpijak pada nilai-nilai dan budaya adiluhung Nusantara. Digitalisasi layanan pendidikan mempermudah masyarakat dan mahasiswa mendapatkan informasi mengenai UT. Selain tercetak, bahan ajar juga diberikan dalam bentuk digital guna memudahkan mobilitas mahasiswa. Dengan demikian, belajar bisa dilakukan di mana saja, kapan saja, dan bersama siapa saja. Digitalisasi pendidikan juga diformulasikan ke dalam loka pasar digital mata kuliah yang ditawarkan oleh Indonesia Cyber Education Institute atau ICE Institute. Beragam mata kuliah dari perguruan tinggi terkemuka di tanah air dan mancanegara ditawarkan secara online. Perpustakaan UT sebagai salah satu unit vital di perguruan tinggi menawarkan fasilitas digital yang memungkinkan mahasiswa, dosen, tenaga kependidikan, bahkan masyarakat umum untuk mengakses sumber pustaka secara lebih leluasa. Beragam layanan yang diberikan memastikan student engagement dapat dilaksanakan dengan better, cheaper, and faster. UT pada tahun ini mengedepankan internasionalisasi program sebagai upaya menyejajarkan UT dengan perguruan tinggi jarak jauh berkualitas di dunia. Selain menawarkan program internasional, akreditasi internasional pun dilakukan. International Trust yang tinggi akan meningkatkan kredibilitas UT dan lulusannya. Public trust terhadap UT ditandai dengan terus meningkatnya jumlah mahasiswa UT dari tahun ke tahun.
Semoga keluar dari sini makin berkah hidupnya, apa yang diinginkan tercapai, dan yang pasti ilmunya bisa bermanfaat buat semuanya.
Tidak saja jumlahnya yang meningkat, komposisi mahasiswa pada saat ini didominasi oleh generasi milenial dan Gen Z. Untuk menjaga kualitas akademik, UT melibatkan BAN PT, Lembaga Akreditasi Mandiri, dan International Accreditation Bodies. Bahkan UT satu-satunya perguruan tinggi jarak jauh di Asia yang secara sukarela dan berkala mengundang ICDE untuk mereview semua layanan di UT. Kita ingin memastikan bahwa layanan yang diberikan telah memenuhi kaidah-kaidah dan standar kualitas yang diberikan oleh perguruan tinggi jarak jauh terkemuka di dunia. Pada tahun ini, jumlah program studi yang ditawarkan berjumlah 47 yang dikelola 4 fakultas dan sekolah pasca sarjana. Kantor UT daerah yang tersebar di seluruh wilayah Indonesia dan di luar negeri memastikan layanan pendidikan dapat dinikmati oleh semua tanpa terkecuali, termasuk mereka yang tinggal di wilayah terpencil, terluar, dan tertinggal, serta di luar negeri.
Mungkin harus menunggu puluhan tahun atau ratusan tahun untuk membangun kampus di tempat ini. Puji Tuhan, dengan adanya UT, saya bisa kuliah meskipun saya tinggal di tempat yang amat terpencil seperti ini.
Karena airku tidak kulupakan, kan terkenang selama hidupku. Biarpun saya pergi jauh, tidak akan hilang dari kalbu.
Meskipun saya TKI di Hong Kong, saya tetap bisa kuliah di UT. Setelah jadi sarjana, saya akan pulang dan menjadi entrepreneur yang tangguh.
Meskipun kaki ini jauh melangkah hingga kutub utara, saya tetap memilih belajar di kampus tercinta Universitas Terbuka.
UT menyalawi.
Dengan semangat 4 dasawarsa, UT hadirkan pendidikan berkualitas tanpa batas.
Engkau ku banggakan.
First of all, allow me to extend our warmest greetings to the Honorable Speaker, Professor Ghasan Budeoun. Also, we would like to welcome our honorable guest today, Dr. Subekti Nurmawati MSI, Dean of Faculty of Science and Technology Universitas Terbuka, Head of Study Programs on Faculty of Science and Technology Universitas Terbuka, and Mrs. Mayang Anglingsari Putri SST MCom as our moderator, and all of the participants of today's event. Om Swastiastu. Assalamualaikum warahmatullahi wabarakatuh. Shalom, Namo Buddhaya, Salam Kebajikan, Rahayu. Welcome to the visiting lecture on Monday, the 18th of November, 2024. Good morning and a very warm welcome to all of participants who joining us physically here and also virtually using Zoom and YouTube. This visiting lecture session is proudly presented to you by the Information System Study Program of Faculty of Science and Technology Universitas Terbuka. Ladies and gentlemen, before we officially start the visiting lecture session, please allow us to first broadly go through the agenda as follows. First, singing Indonesia's national anthem. Second, welcoming speech that will be spoken by Dean of Faculty of Science and Technology Universitas Terbuka. Third, visiting lecture session with Professor Ghasan Budeoun, followed by Q&A session. Fourth, delivering certification of appreciation to the speaker. Fifth, photo session. And last, closing. In addition, all of participants of today's event will get a certificate by filling the attendance form by clicking the link that will be shared by committee at the end of today's event. Ladies and gentlemen, to begin our beautiful event today, let us listen to the national anthem of Indonesia. Please stand up from your seats while listening to the national anthem of Indonesia. Thank you. You may now take your seat. Ladies and gentlemen, as we gather here today, let's pray together according to our respective religions and beliefs. Let us take a moment of silence and start praying. Swaha, Amin Ya Rabbal Alamin. May God give His blessings and grant our wishes. Ladies and gentlemen, let us hear welcoming speech from Dean of the Faculty of Science and Technology Universitas Terbuka. Please welcome Dr. Subekti Nurmawati, MSI. Dr. Nurma, please come forward to deliver the welcoming speech and the time is yours.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Good morning and best wishes to all of us. Alhamdulillahirabbil alamin, in this very fine day, we are able to gather in this visiting lecture activity, and it is our privilege that we can join in the hybrid meeting. Our Honorable Professor Ghasan Budeoun, Professor and Deputy Head of School of Systems Management and Leadership, University of Technology Sydney, right? Our Honorable Vice Dean, but actually Vice Dean get other activities, and I apologize that they cannot come here. All head of study programs, especially information system. Is it Bu Yani here? Okay. Ibu Mayang Angling Sari Putri, SST MCOM as moderator today. All lecturers of FST Universitas Terbuka and our students of the Faculty of Science and Technology UT who attend virtually. And also there are many lecturers from brand offices who comes virtually. Firstly, praise is to Allah Subhanahu wa Ta'ala because of His permission that today we are all able to attend the visiting lecturer from our extraordinary speaker, Prof. Ghasan Budeoun, current information technology and focus on sharing of complex knowledge. Okay. Prof. Ghasan, welcome to Universitas Terbuka. You said that this is for the first time you visited Universitas Terbuka, and you was previously as a keynote speaker at Ainodel, a seminar in Medan, North Sumatra. Today he will share the topic with all of us. This event is organized by Information System Study Programs. Dear visiting lecture participants, in this visiting lecture, we will discuss many things about complex knowledge. We'll share from Prof. Ghasan, and it is very related to our activities as a lecturer, also to all of students. As a piece of information, the number of FST students about closely to 50,000 students who widespread in all over Indonesia and I think the world, all over the world, yeah. And the most student of FST is System Information study program. The half of our FST student, about 24,000 our student of System Information study programs. And currently, we hope that these activities will continue our MOU or MOA between Universitas Terbuka and also UTS for the next activities, not only for visiting lecturer, and we can create a collaboration in research, I think, or probably our lecturer will continue the PSD in UTS in Sydney, hopefully. And we hope that this activity can useful for us. We can get advantage for this visiting lecturer. And thank you for Sistem Informasi Study Program who organize these activities. That thanks you once again for Professor Ghazan, and this all of from me. Thank you very much. Wassalamualaikum warahmatullahi wabarakatuh.
Thank you, Dr. Nurma, for giving a warm speech. Distinguished guests, ladies and gentlemen, we will now continue to the main agenda for today's event. Visiting lecture with the theme of current information technology that will be delivered by our honorable speaker, Professor Ghasan Budeoun. He is a professor of information systems, University of Technology, Sydney, Australia. For this section, I would like to give attention to all the participants who joining us virtually for these following matters. First, please open your camera and turn off your microphone during this presentation. If you have any question, please write it down to the Q&A section with format your name, _institution, and then your question, or you can ask directly by using the raise hand feature. It is expected that all participants to fill the attendance form with link that will be shared on chat box at the end of this event. We will share link for attendance form later. Okay, ladies and gentlemen, this session will be moderated by Mrs. Mayang Angling Sari Putri, SST MCOM. Now I would like to invite Mrs. Mayang and Professor Ghazan to guide us through an insightful lecture. Mrs. Mayang, if you may guide this visiting lecture, this session is yours.
Okay. Good morning, everyone. Welcome to the visiting lecture on current information and technology. My name is Mayang Ningsari Putri. I'm the lecturer in Information System Study Program, Faculty of Sains and Teknologi Universitas Terbuka. I'm happy to be your moderator today. Today, we are very lucky to have the special guest, Professor Ghasan Budeoun. Professor Ghasan Budeoun is a lecturer in University of Technology Sydney in Australia. Professor Budeoun is the specialist in information system, and he is here now to share his knowledge with us. Before we start, let me explain how the session will go. First, Professor Ghasan Budeoun will give his lecture. After that, we will have the question and answer sessions. And please feel free to type your question in the chat during the lecture. We will choose the sum of them and answer the latter. Or if any audience member have the question, please raise your hand and ask the question. Thank you very much, Professor Budeoun, for being here today. And we are very excited to hear your lecture. Now, Professor Budeoun, please start your presentation. The time is yours.
Such a pleasure to be here. Assalamu alaikum wa rahmatullahi wa barakatuh. And I've also learned to say Horas. I don't know if it applies to Jakarta or not. It's been such a wonderful opportunity to be in Indonesia, in Medan, and I've seen stuff that I'm so amazed at the beauty of the country and the hospitality and the warmth of the people. So thank you very much for creating this opportunity for me to be here and enjoy the Indonesian culture and the education and learn about the education system of Indonesia. I'm a professor of information systems at the University of Technology of Sydney, and I'm also the head of the information systems discipline at UTS. And I heard that there are 24,000 students studying information systems at UT. We don't have that at UTS. We have about 1% of that of studying information systems. So our discipline, we probably have about 200-300 students studying information systems. That falls under the information systems discipline. I did my PhD many years ago, 25 years ago almost, and my area of expertise is knowledge engineering. So knowledge engineering is essentially looking at the world, the environment around us, and trying and describe the world in a way that the computer can access that description, that representation of the world. And that's a common thing we do all the time, but often it's not done systematically. So my expertise in research is really conceptual modeling, which means looking at the world, taking concepts in a way that humans can understand and talking about the relationships between these concepts and putting all this into a computer so that you can use algorithms and you can use AI and you can do rule-based systems over that description and you can ask intelligent questions. So I've been doing this pretty much since, the mid-90s, way before AI came along. Well, I knew about AI. My PhD was on AI. Many people talk about AI these days as if it just happened the last 5 years. But really, AI started before computer science almost. AI started in the late 40s. So as a PhD students, we used to go through the history of AI from the 50s to the 90s. But now what happened in AI recently is that computers gotten much faster and we can do a lot more things that we couldn't dream of doing, say, 20 years ago. So back to my research agenda and what I've been doing over the past 10, 15 years in the information systems discipline is I've been focusing on the specific types of problems, human problems, where you have to access knowledge sources. So, and by access knowledge sources, I mean, before you execute whatever is it that you want to do as a human being, you have to reach out and get knowledge. So students, of course, they do this all the time, but so do many other people in many other activities. So I've done a lot of work in disaster management, for example. So in disaster management, when a disaster strikes, you have people who are involved in responding to the disaster. And it's their job to know how to respond, and they access things like disaster management plans, and they also have to know who's in charge of what. That's just to give you one example. Online teaching, obviously, we all use to online teaching, and we all have to access lectures, and we have to know who's the tutor, who's the lecturer, who's the coordinator, and depending on what we do, sometimes we have to know who's the dean and so forth. In software development, if you look at the software developer and they've been tasked with that, $1 million software development project. You have a project manager. The project manager has to know what the development methodology is, what are the various roles of the software developers on the team. You have the systems analysts, you have the coders, you have the testers, and so forth. So somebody has to know all these things, and these things often are reusable. So meaning that if you take a project manager and software developer, he's going to be reusing the same knowledge over and over again. And if you take different software project managers, they're also going to be reusing the same knowledge over and over again. Now, the problem with reuse that I've been considering in my research And when I say research, I mean my PhD students over the years and teaching assistants and postdocs, depending on the funding, is how do we maintain this reuse knowledge? So when people access some repository of knowledge, be it in disaster management, software development, it's not easy to access that knowledge. And sometimes the knowledge to access the knowledge is lost. So every time a project manager comes along to access a particular software development methodology, they have to figure out their way of accessing that knowledge. So some of the stuff that some of the challenges I look at in my research is how do we reuse this process knowledge quickly? And often you are faced with different situations, say as a project manager, or as a student, or as an online teacher, or as a disaster management practitioner, is that you see these various ways of doing things, but none of these various ways is applicable fully. So reuse often comes in the form of partial reuse. You only want to use that part of the project management technology, or you only want to reuse that part of the disaster management knowledge, or you only want to reuse as a student only those lecture slides from that subject. But ideally, you also want to be able to mix and match these various bits and pieces to address challenge that you're looking at. So if you're a student and you want to learn something about web programming, you might find something relevant in the contents of this subject, something relevant in contents of this subject, and so forth. And you want to be able to mix and match according to your interests. And as I said, this happens in disaster management, this happens in software development, and in many human endeavors. So some of the challenges of so these are some of the challenges I've dealt with in my research. And by challenges, I mean each one of these challenges, I had a number of PhD students working on those single challenges. So one of the key observations of my research, if you like, is the premise or the hypothesis of my research agenda is, although that all these types of knowledges are different, disaster management is different to online learning. It's different to software development. It's different to procuring large infrastructure project. That's another area I worked in, or in energy planning. All these kinds of knowledge are different. But the observation that I guess my research is based on is that all these types of knowledge, you have humans around them, and what is constant or what is static between these different problems is that you have human roles, human stakeholders, and the description of these roles is the most steady element of all these domains. So if you take a disaster management plan, you would have certain roles in disaster management, like a local controller or people on the ground, and you can describe their roles very specifically. If you take, and those roles are steady, be it 30 years ago, perhaps 20 years in the future. Same thing with online teaching. We've always had lecturers, we've always had tutors, we've always had subject coordinators. So you've got human organizations that are steady across all these different domains. So which leads me, I guess, to the next part of the next slide. Next slide, please. That slide is actually one. Yeah, the one before. Yeah, the next one. Yeah, the one after this one. Next. That's it. Perfect. How does it change? Please. Which takes me to the my focus of my research within the knowledge reuse is what's called agent-based knowledge analysis. So from within artificial intelligence, there's a software engineering area within artificial intelligence called agent-oriented software engineering. And that area is 20 years old, so it's not super recent. And that area looks at systems analysis of distributed artificial intelligence systems. So it's a software development process for distributed artificial intelligence systems. Now, in distributed artificial intelligence systems, instead of people talking about class hierarchies and object-oriented programming, they talk about agent-oriented analysis. So you have things called agents, and these agents, so we are human agents, but in AI you have software agents, and agents sense their environment. They take sensory input and they produce effect on the environment, and they have tasks and so forth. So agent-based analysis is the central approach that we've discovered that it is really handy in trying to capture this organizational knowledge across these different domains. So I guess I'm trying to motivate why agent-based knowledge analysis is really a beautiful vehicle, really, to do knowledge reuse. Because the human organizations are steady, but knowledge changes. And if we focus on the human organization as the basis of knowledge retrieval, we can solve lots of these knowledge reuse problems, which is what I will be showing you I guess in this presentation. So to apply agent-based knowledge analysis retrieval across these complex domains, essentially we have a methodology where the first thing you need to do is you need to come up with an abstract knowledge that unifies the various resources. At Inondel, a couple of days ago, I shared with the audience an abstract representation of how do we personalize online access. How do we what is the personalization knowledge? So we came up with a small language for personalizing online resources. What I will show you in this lecture is a unification language for disaster management. So it's the same approach. So if you want to do software development knowledge reuse, it's important to come up with a language that describes these various software resources across different knowledge repositories. If you want to do the same in online resources, you come up with a unification language across these various online resources. So what I will show you is essentially this process, the first step of which is creating a unification language within the context of disaster management. And I'll show you how we use the stakeholder roles and context to retrieve the knowledge once we unified it. So the idea is you first have this unification language, and once you have the unification language, you can put the resources and you can access all these resources as a single repository. And once you have this single repository, then you can access that single repository using the organizational descriptions. And as I said, I've done some work similar to this in online learning systems, which is what I've talked about at Inondel. And I've also done some work in the space of farming. But I've done a lot of work in disaster management, and some of my students were actually Indonesian students. There's a Professor Dedi Anan, he's at University of Papua. I'm very proud of him. He became professor last year. He did his PhD with me in Australia. I think he finished in 2015. So some of this work was done with Professor Dedi, and I think many of you can go and visit him at University of Papua, which I'm not sure where it is. I know it's in Indonesia, but where I'm not sure. And I've done work with state emergency services and disaster management entities in Australia, like New South Wales, Victoria, and some farming companies, BeLife, and some software companies like Surround Australia and Rich Data Corp. And I think on some of the stuff that I'm going to show you on these slides, there were 4 different PhD students. Dedi was one of them. There was another student. She's now, I think, senior lecturer in University UTM in Malaysia. Her name is Dr. Siti Othman. And there have been research assistants as funding permitted. So within the context of disaster management and this architecture system, next slide, please. Yeah, thank you. So this system architecture could be used in disaster management. It could be used in online learning. It could be used in any type of knowledge that you are faced with challenges of knowledge reuse. And the idea is that you have a knowledge repository. In the case of disaster knowledge management, that's the yellow box on the right. And then you have different types of stakeholders that sit outside the system. So in the disaster management, there's local authority, emergency coordinators, researchers, or users monitoring the what's going on. And all these users, they have different types of interactions with the system. So the knowledge that any one of these users needs would be completely different. But all that kind of knowledge would be sitting in that repository. Now, my research in knowledge engineering really is about creating that blue box on the left. And that blue box is like the gateway that enables different stakeholders to access that repository of knowledge. So what I will show you on the next few slides is how do we create that yellow box and what does the blue box look like, which is the tunnel into the yellow box. And at the end of the presentation, towards the end, I'll talk about the implication of AI, modern AI, and what we are trying to do with modern AI to enhance these blue boxes and the yellow boxes. Next slide, please. So the blue box that unifies all the various knowledge is called the meta model. So it's a model about models. I mean, most of you here in information systems or in computer science would have heard about models or stuff like UML, Unified Modeling Language, in object-oriented modeling. So above UML, there's if you like, you can think of UML as a meta model. So UML unifies all the various models for object-oriented models. So in this methodology that I'm showing you to knowledge reuse, you essentially create a UML equivalent to the domain that you want to work with. So if you want to work on disaster management, you create the UML equivalent for disaster management. If you want to work on personalization of online content for students, you create the UML equivalent for personalization, and so forth. So what I will show you is how do we create these meta models and how we did it for disaster management. But I'm happy to talk about online content as well. I've got a couple of slides. So the idea is that we create the first step is we create a meta model. Okay, jump to the next slide. Thank you. Before asking, but that's okay. And this meta modeling, the picture that was on the previous slide, we didn't actually invent that picture. That picture existed since the late 90s by OMG. There's an international body called Object Management Group. I don't know if anyone has heard of OMG. And OMG is the body that created UML. And OMG is, if you like, to software engineering what ISO is to standardization. So with OMG, you have Microsoft as a member of OMG, you have Oracle is a member of, so all the big companies are members of OMG. And OMG came up with this, the previous picture, previous slide, please. OMG came up with this OMF called OMG Meta Object Facility Standard for Model-Driven Engineering Meta Modeling. And the problem that they were looking at was completely different to what I'm talking about now. Essentially, they were looking at how do we combine databases from different platforms, Oracle, Microsoft, and what have you. How do we get these databases to interconnect? And that's something that they were working on in the 90s. Now, our observation is, essentially, if you follow their view of the world, you can do lots of stuff. You can unify domains, not just databases. you can unify disaster management plans from different sources, different repositories. You can unify personalization attempts across different online content as well. So what this is really, to understand it, it's a simplification algorithm on how to engineer knowledge about the world. The world is very complicated, as we all know. And what this says is, we're going to simplify the way we look at the world. We're going to just think of the world as 4 layers of abstraction. That's all. Where we have the world sitting at the very bottom, where we have objects and we have things happening in the physical world around us. And above that, we're going to have a picture of an instance of time of when things are happening. And then above that, we're going to have a meta picture of how do we talk about these various pictures. And this is where UML comes. And then above that, we have a philosophical picture and logic. What are the basis of us creating this unifying picture? Of course, the world is not 4 layers. You know, the world is very complicated, but for the purpose of computers and database systems and and computational models, this body OMG said, look, software engineers all over the world assume that the world can be described into these 4 layers. Next slide, please. So we took that assumption. Again, if you like, our contribution is observing that that assumption is actually applicable in many human endeavors, not just software and database systems. So we took this assumption and applied it to disaster management. And we came up with this, if you like, UML for disaster management. And our contention, and this was done with Dr. Siti Othman, who's now a senior lecturer at University of Technology in Malaysia. So all the papers about this will be co-authored with Siti. So this is essentially a disaster management language. So this is to disaster management what UML is to software development. So the contention is, if you take any disaster management plan anywhere in the world, you could take concepts from this and describe that disaster management knowledge. So that was the PhD of Siti, which finished, I think, around 2010 or 11. And you can say, well, how do we know that? How could you be sure that this is the language that represents all disaster management plans? We're not sure, but the way we've done it is we've looked at 86 different standardizations for disaster management, and we applied meta modeling, that standard that I showed you earlier, to distill what's in those 86 standards into this. So this is kind of zooming in a bit. So this is the preparedness. Next slide, please. Thank you. So this is the quarter of that disaster management language. So essentially, this is it's saying that, you know, in disaster management plans, you have public education, you have public awareness, you have early warning systems, you have media, you have emergency public information, and this is all part of the preparedness phase of disaster management. So if you take any disaster management plan, disaster management plans often talk about preparedness or response or recovery. So if you take the preparedness, any preparedness knowledge, you should be able to describe it in terms of these concepts. So that's the UML equivalent to disaster management. And once you do that, so the idea is you take all the various disaster management plans, say for Indonesia or for Australia, we've done this a bit in Australia, you convert the document to concepts from this language. And once you convert your document to concepts of this language, then you can put this converted document into a database, and that database will be able to contain all the disaster management plans from all of Australia, for example, or all over Indonesia. And once everything is represented in a unified fashion, then you can access it. anyone can access any part of the disaster management plan. And then the challenge becomes, which part do I access? And our response to that challenge is you use the organizational knowledge, agent-oriented analysis. So I guess I'm just building up the story bit by bit so that, and I hope I'm keeping most of you with me as I move forward. So I've already spoken to this. This is where Professor Dedi, now I call him, at the time he wasn't Professor Dedi, he was just Dedi. Professor Dedi, as I said, is now Professor at University of Papua. So the challenge that we were faced with, okay, now we got the language that combines all these disaster management plans, but it turned out, and that's not a challenge that City had time to deal with. That was one PhD. The challenge was, okay, if I have a disaster management plan, how do I actually convert it to that language? So the reverse, some of you may be familiar with object-oriented analysis. So the reverse problem or the equivalent problem for this in object-oriented analysis is, if somebody gives you a specification of a system, how do you convert that specification into class hierarchies, sequence diagrams, and so forth? It's not easy. You need a systems analyst. And that's what systems analysts get paid for. So for every problem that I mentioned, disaster management or online personalization, there is that step that is equivalent to systems analysis for the domain. And it's not an easy step. So our answer to this is agent-oriented analysis, because the human organizations are really built up around human roles and agent roles and relationships between these roles. Often the knowledge about these, the knowledge to be reused is really a description of how these roles interact and who should do what and when. So that's the second critical observation, is that reusable knowledge lends itself naturally to agent-oriented analysis. And that shouldn't be a surprise, because we are all human beings, and the way we talk about our knowledge often relates to other human beings and what they should do and what we all should be doing in a given context. Software development, disaster management, teaching, or whatever. We are always talking about what human beings should be doing. So the systems analysis exercise and the knowledge reuse now follows agent-oriented analysis. That was the hypothesis that we started with at the start of Professor Dedi's PhD thesis back in 2010, I think. Now, as I said, he finished 2017. So he quickly became professor, power to him. So the idea is, we take agent-oriented analysis and we apply agent-oriented analysis to these documents that we want to share amongst ourselves. And we take the output and we combine it with the modeling language, which is what I'm going to show you over the next few slides. So one thing about agents, I guess this is a philosophical point, just to pull in people from outside the field as well. What agent is an entity that is rational. So crazy people cannot be described as agents. So, and rationality is something that's very well defined. Rationality essentially means that everything people do is towards a particular goal that they have. So all action, in other words, all actions are goal-driven. So if there are actions that are not goal-driven, that's outside the rationality. So that's not so agent-oriented analysis, if you like, it gives us an ideal picture of how humans are. It ignores lots of features of humanity, emotions and everything else. It just says, well, agents are rational entities and all actions are constrained by particular goals. And then once you make that assumption, you can take the knowledge about humans and put it into these agent-oriented templates. Next, please. Okay, so we took this assumption and we applied it to, in the course of Dedi's thesis, and some of it came after. we applied agent-oriented analysis to disaster management plans in New South Wales, where there was 128 local government area plans, and there was some response plans, and we did that for floods. So in Indonesia, we know that there are lots of different types of disasters. In Australia, we have roughly, the main one is floods, and there is some bushfires, but the one that we did a lot of work in is floods. We did some work actually in there was a volcanic explosion in 2019, I think Mount Agung in Indonesia. Dedi did some work in that in volcanic eruption, and there was a paper that appeared on that in 2019, if anyone is interested. Next slide, please. So what did agent-oriented analysis give us that the normal disaster management plans do not give us? So with agent-oriented analysis and the disaster management language, we solve lots of problems of disaster management plans. So the many disaster management plans, they overlap. So you don't know which plan starts or should start when the other one finishes. So they text documents, and people who are using, in the case of floods, you've got local council areas, but water doesn't recognize council areas, obviously. So many of the plans are just that you don't know when to use one and when to shift to another one. So by combining everything into one repository, we can just ignore those unnatural barriers, because then all these plans are accessed from a single point. And there were inconsistent knowledge in some of the plans. So some, and incomplete knowledge. So some plans would talk about a local area controller, but then you don't know everything that the local area controller needs to do. And there'd be sometimes actions that it's not attached to any particular person. It just says this needs to happen, but it doesn't tell you who needs to do it. So agent-oriented analysis applied to disaster management plans solved all these problems for us. Now, yeah, thank you for moving. So this picture is actually describes how the retrieval can be done with agent-oriented analysis. The red, and this is, if you like, this is the outcome of Professor Dedi's thesis, this picture. So these red words, there's the word agent, the word activity, the word environment entity, the word goal. All these words, they come from the agent-oriented analysis stage. If you look at these black words, exposure, preparedness, evacuation, warning, public awareness, media, emergency public information, these black words, they come from the disaster management language. So essentially what this is, it takes the meta model of disaster management, that language. It takes the meta model of agent-oriented analysis, the language on how do we describe agent-based models, and it combines them. So this picture, if you like, it's like a cross product of disaster management meta model and an agent-oriented meta model. And once you have this picture, then you can access all the various media instances or actions using the word environment entity. So then you have the words environment entity will give you access to things like exposure, preparedness plans. And why is that important? Because the word environment entity and activity and so forth, an agent, these are words that are common in all application domains. So if you are talking about teaching, if you are retrieving online material and you want to personalize, there are There are agents in the online teaching space. There are activities in the online teaching space. There are goals in the online teaching space. There are events in the online teaching space. But when we did this, obviously we weren't talking about the online teaching space. That happened after. That was the project after we did in disaster management. So the beauty of this approach is that these red words or these red labels are, if you like, domain agnostics. And these are the organizational words that allow you to retrieve knowledge about any domain. So if you're doing online content personalization, you need to identify these red words. How do you identify these red words? We know how to do it. That's essentially using agent-oriented analysis. So if you use agent-oriented analysis, what you end up with is you end up with these red words attached to your knowledge sources. So if we apply agent-oriented analysis to online content, doesn't matter what subject, any subject, you end up with these words attached to your documents. But if you want your documents to come from different sources and you want to be able to mix and match different documents, then you want these red words to be attached to something more abstract than your documents. You want them to be attached to a language that describes various documents, and then you can mix and match different documents. But you can access the mixtures of different documents using these red words, these red tags. Now this is kind of looking, next slide. This is looking at things in a bit more details. So about the beauty of the red words and where these red words come from. So if you look at agent-oriented analysis, there are things called like the goal model, the organizational model, the scenario model. And I have to be clear with you, this word goal model, organizational model, scenario model, we did not invent it. So there are agent-oriented analysis templates out there, the same way that there are object-oriented analysis templates. You know, you have class hierarchies, you have sequence diagrams, and what have you. In the agent-oriented space, there are things called organizational models, and the closest thing to organizational models are organizational charts. We were talking about the organizational charts of UT with Dr. Alan Bruce this morning. We were talking how complicated the organizational chart of UT is because it's such a huge organization. So these organizational models, they often exist. So for UT, you do have an organizational model already. But of course, if you want to use it, if you want to use something specifically with an online knowledge reuse, you probably need only one part of it. And maybe you need all of it. I don't know. That needs analysis, for example. The goal model, this needs further analysis. So the goal model depends on the agent. So students will have different goals. Lecturers will have different goals. And of course, there are some goals that overlap. And sometimes there are shared goals, and you have multiple agents working towards the same goal. Again, all these relationships between the agents and the goals and the various roles, that's what the goal analysis does. So agent-oriented analysis, parts of it captures this. Scenario models become like examples of how these goals look like, you know. So we used 7 different agent models, and we came up with a conversion between the documents and these agent-oriented models. And as I said, once you have your agent-oriented models, you've got really beautiful tags that you can attach to your online sources, and you can extract according to the context on hand. Because it's always much easier, next slide please. It's always much easier to describe the context on hand in terms of agent-oriented analysis terms. You know, you can say this particular agent student wants to study this particular subject with this particular teacher for this given time, and they want to see each other 5 times per semester and what have you. So that it's easy enough to describe the constraints of online teaching in those terms than any other terms. And you can do that in any domain, as I said. In disaster management, you can say, I want a team from this area and a team from this area to go and save those people in that particular area within 2 days or what have you. And these things, again, as I said, they can be described within the agent-oriented models. And the other thing that we discovered about agent-oriented models as we did this, I mean, essentially what we did is we played with agent-oriented models. We played with OMG, the meta modeling framework. And one of the things we discovered, which was extremely handy, is that different types of agent-oriented models are more suited for different layers in the OMG hierarchy. So if you take the higher level models, the higher level layers like M2, the UML side of things, it turns out the goal model and the organizational model are a lot more useful. The organizational model, for example, is extremely useful at the higher levels, which is not so surprising because it abstracts above the actions. So you don't talk about actions when you prescribe people's roles. But if you take some of the environment model and the scenario model, they tend to be very useful at the more action-oriented parts of our view of the world. So if we are talking about specific disaster, Mount Agung blew up and, specifics of time and space, these things like the environment model and the scenario model become more useful. The next few slides, that's essentially how we implemented all of this so that you can see that all this description actually translates into an actual database system. So there was a MySQL server, Microsoft, and above Microsoft, we built an agent-oriented retrieval interface. And that retrieval interface, you specify the query in terms of agent-oriented constraints, and that gives you the contents that you actually need. This is some details of the system. How much time do I have? 5 minutes, okay. One thing you don't do is you don't give an academic a microphone and you don't tell, and without telling them how much time they have. Okay, thank you. Yes, as I mentioned, Dedi did some work with this, and I worked with Dedi with him on this, using agent-oriented analysis to the Mount Agung eruption in Indonesia, and that was published in this journal, if anyone is interested, International Journal of Disaster Risk Reduction. This is the meta model. I didn't speak to it a lot at Inondale because, again, they gave me a microphone and they didn't tell me how much time I have. So I didn't. When I got to this slide, I didn't have too much time. It's okay. I'm just joking. So I think we can take this during the Q&A phase. So these are the concepts for the online personalization domain. Again, I had another student, coincidentally, he's also an Indonesian student. His name was Alva Muhammad. I don't know what he's doing now in Indonesia. I don't think he's working at the university, but yes, he's Dr. Alva Muhammad. We did stuff, meta modeling and for personalization of e-learning. Just to give you an idea how this approach looks like in personalizing e-learning, he did something similar to Siti, and he went through various resources on how do we personalize e-learning. And these are the concepts he found across these various frameworks for online personalization. Online personalization is essentially recognizes that every student is different, every student has different context, and the more you can adjust things in presentation, in content, the better for the student. And there's lots of literature on this. So Alva went through the literature and he came up with a meta model, and he divided these various concepts into 3 phases. So the same way that we had these 3 subsets in disaster management, there are 3 subsets because learning is not phases. So there's a subset of personal user characteristics, the user, in this case, the student. There's concepts related to previous knowledge and skills that the student had. And then there are concepts that are related to the IT system access. So if you look at these concepts, it talks about network bandwidth, device, preferences, goals, tasks, teaching history, time, topic, interests, and so forth. Previously acquired knowledge and skills, there's course, instructional plan, knowledge level, background, and so forth. User characteristics or student characteristics, there's language, age, occupation, gender, learning style, personal information, and so forth. So there are lots of models, student learning models that describe the student learning process in these concepts. So Alva identified these concepts as a way of unifying all these ways of characterizing online learning. And that was the architecture of this process. So I'll just can go back to it during questions time if needed. So next slide, please. Sorry, I haven't. Next, you've been. Yeah, sorry, I've been saying next. Go back to the previous one so that everybody knows what I was talking about. Yeah. The previous one. So when I was talking about the concepts, next one. No, stop. So when I was talking about the meta model of online learning, sorry, I forgot to say next. That's what I was talking about. Now go back to the slide. Yeah, just leave it there, please. Yeah. So this is the meta model for online learning. So when I was talking about the concepts and subsets that the work that Alva did, that's what I was referring to. I'm happy to share all the slides with the audience. So this is a rough description of the personalization meta model for online learning. Next slide, please. So, and this is how the personalization of meta model was used pretty much. So you need an adaptive e-learning system that's based on agent-oriented analysis, and then that meta model I just showed you would sit on top of all the online concepts. Next slide, please. Now, I'm going to conclude by talking a bit about AI and how it connects to what we're trying to do. This method that I showed you, how we unify access to various knowledge sources, be it online learning, disaster management, or what have you. Now I have a few students, 4 students actually, working on the following problem. Instead of creating a meta model using the OMG framework, I have a couple of students working at the problem of expediting the creation of the meta model using large language models. So I don't have results to show you. I have some ideas to share with you because this is the current generation of my PhD students. So maybe in 3-4 years, I'll have some exciting story to share with you. So what we're trying to do is we want to use large language models to take lots of different resources. Instead of looking at 100 disaster management modeling standards, we want to look at these as a text chunk instead. And when you look at this as a text chunk and feed that into a large language model, it may well be possible to create something like the meta model, but do it quicker, do it automatically. So our idea is to follow this is we want to create a meta model quickly using large language model. And then once we have that meta model that is created quickly, I mean, you could create it slowly, but we want to try to create it quickly. We want to use that meta model to help prompting the large language model properly. So instead of the yellow box on the that I showed you in the very first diagram, we want to have a large language model sitting on top of all the contents. So instead of having a repository of all the disaster management plan, we want to create a large language model that is trained using the disaster management plan. Instead of having online content, we would want to have a large language model that is trained using the content. And it's possible to do that. It's computationally expensive, but if you have enough resources and you have enough money, you can get AWS to do it. You can, you give them 100,000 or whatever it is dollars, and they'll do it for you. But that specific large language model, it's important, as many of you know, I guess, if you've been keeping track of large language model, is hallucination. That sometimes large language models, they tell you stuff that's off the track. This is where this what we call the RDF knowledge graph that's coming out from the first large language model could help. So this architecture, currently we are working on this. And as I said, I recruited, I have 4 students, 2 of them recently working specifically on this architecture. And we are working on it we are trying it currently in medical domain problems, where you can look at lots of medical research papers, instead of the RDF, instead of the disaster management plans, we can just feed in medical research documents. So that's the next experiment that we are working on. So I think that's the end of my slides, and we'll stop here, and it's probably more fun to take questions and to interact with the audience. Thank you very much.
Thank you, Professor Budeoun, for the great presentations. If any audience member have the question, please raise your hand and ask the questions. Okay. Okay, I will read for chat in Zoom. What are the main benefit of using knowledge unification language synthesis method in the business area?
Again, a very good question. So if you think what language does to us as humans, it allows us, if I learn the Indonesian language, it will allow me to interact with people who speak Indonesian better. So essentially, language itself is a knowledge sharing communication. Now, if we take different documents, different disaster management plans, and we describe them in the same language, what we can do then, we can do mixing and matching across different disaster management plans. So it becomes easier to customize actions for a given context. Then you can take, say, 10% of this plan, 10% of this plan, 10% of this plan, and come up with a new plan. So the mixing and matching between different knowledge sources becomes a possibility.
Yes, it's good answer. Maybe in there, if any audience member have the questions. Okay, Mr. Hassan Basri from Information System.
Okay, I'm Hassan. Thank you for your presentation. I have a question. What are the initial steps to prepare an optimal knowledge base for processing with tool like long chain?
Like long chain?
Yes.
No, that's a very good question. So that's you're referring, I guess, to the last slide. That was, isn't it? Can we have that last slide, Sean? So that the audience, because many of the audience, they did not probably pick up long chain. Last slide 20. Yes. So the question is, what is the first step to use long chain to create knowledge repositories? For those of you who haven't heard of long chain is a new, if you like, a software development tool. I think Microsoft is behind it, if I'm not mistaken. It allows you to create customized interfaces to large language model. That's essentially what long chain does. So you can do component-based software development. So you can quickly get a large language model-based system up and running quickly. So with long chain, one of the early steps is you have to decide what large language model you want to use. So if you want to use OpenAI, you have to tell long chain. And there are lots of these different large language models. So OpenAI is just the one that everybody knows. So with long chain, you tell which LLM you want to use, and then you need to decide on the queries. Some of these queries are usable and some of them are not reusable. And one of the beauty about long chain is it integrates a large language model with what's called a RAG, retrieval augmented generation. So what long chain allows you to do is you integrate large language models with a pre-populated database. So your steps would be to give knowledge sources to create this database, the RAG. It's called the RAG. And then you specify how you want to interface the RAG with the large language model. And it sounds like it's complicated, but if you look on YouTube, and you probably can teach yourself how to use long chain in a few hours. So it's, if you're interested, so essentially you have to decide which large language model. You have to decide what will be the basis of your RAG, which is text documents. So RAG can be built in different ways. Now, what we are trying to do in this research with the one I mentioned is not RAG. There's a new generation of supporting large language models that's called the graph RAG. And our hypothesis is that instead of graph RAG, instead of the meta model, why not try graph RAG? Because graph RAG is complicated enough and it may well have enough complexity to replace our view of meta model. Yeah, did I answer your question? Yeah. In long chain, by the way, is an open source tool. So, that's why my students, I'm encouraging them to use it, because you don't have to pay money to use it. But the one caution about the large language models is some of them require a huge amount of computation if you want to train them. So I don't know whether you have high performance computing at UT or not. At UTS we have, but even with that, it's not enough to do everything that we want to do. But you can outsource that, So if you want to train your large language model, which is the stuff on the right, even the stuff on the left, but the stuff on the right, if you want to train your large language model, can be extremely computationally expensive. So you wouldn't be able to do it on a normal computer. But you can ask your dean nicely. They may give you money and access AWS. That's how we bypass in this problem. But we work with industry partners. So we usually say to the industry partner, you want us to help you to do this, that's how much it will cost, because we're going to pay money, for AWS or what have you. And there are, it's like going to the supermarket doing these things, If you want particular amount of computation, they have there's a shopping list, and they're happy to. I mean, it's a common request to AWS.
Okay, thank you, Professor Budeoun, for the great answer. Maybe one more questions. If any audience member have a question, please raise your hand and ask the question. Okay.
Okay, thank you, Prof. Ghasan. I'm really curious about the disaster management. What kind of disaster? Is it all of kind of disaster, or probably flood, earthquake, or other? and how to build the system based on the database, or we can build to forecast the disaster. That's my question.
Yep. Thank you for the question. That's a real question. Can we go to slide 8, please? Yeah, I think this slide, I didn't talk a lot about it because I was mindful of the time. So the approach is not really about specific disaster. So we have, with OMG, we have 3 layers of abstraction. There's level M0. M0 is a specific disaster. So we had examples of Victoria bushfire, which was a specific disaster. When the Mount Agung erupted a few years ago, that was a specific disaster. So the knowledge pertaining to a specific disaster is described at level M0. The knowledge described about a disaster management plan. So the Indonesian authorities, they could have evacuation plans about, when the volcano erupts, what should happen. So that's kind of preparedness. So the preparedness element of the knowledge elements, they are more at the M1 layer. The meta model that I showed is at the level M2. So we covered the M2 layer, but the architecture of the repository is flexible to any type of disaster. But the specific disaster falls at the M0 layer. When we were doing this work, one of the things that we learned after Siti finished her PhD, before Dedi came, was that it's actually difficult to get the repository about multiple types of disasters because the way it happens in Australia, at least, is that we have a flood disaster management plans, and that's the State Emergency Service. And then we have the bushfire, and that's the Royal Fire Services. So completely 2 different organizations. So if we say to them we want to combine the fire service with floods, they'll probably say, oh, well, we don't know what to do with that. We don't want you to do that. So we started to focus on combining the same types of disasters. So when Dedi was doing his PhD, he combined flood disaster management plans from different areas in New South Wales, and it was a lot easier to develop the repository quickly. So it's really, theoretically, it's easy to combine different types of disasters. But just because the way human organizations are organized, often it's more convenient to focus on specific types of disasters. In terms of forecasting, the second part of your question, in terms of forecasting, it depends whether people have that knowledge or not. So this approach is not about creating knowledge from scratch. It's more about mixing and matching existing knowledge from different sources. So if some of the, so the authorities around Mount Agung, for example, if they had some knowledge on how to forecast, little earthquakes, and they had this knowledge in their disaster management plans, then that forecasting knowledge would then be easier to access. And we could integrate it with existing knowledge. So the answer to the forecasting, if people have forecasting knowledge, then by unifying the forecasting knowledge with the rest of the disaster management knowledge, then the forecasting knowledge would be accessible easier, which might help in the forecasting. But if people didn't have forecasting knowledge, then yeah, it doesn't help. But in most cases, I think it depends on the disaster. Volcanoes are probably one of the easier ones to forecast, although not 100%, because they look at sensors on the mountains, and when sensors start to operate outside certain limits. So in the case of volcanoes, it makes this integrated with other actions, and people may feel that, well, if we acted earlier, so they can make their forecasting link to actions more effective links. Earthquakes, it's very hard to forecast, so I don't know if much can be done in that space. Yeah.
I think really help to mitigate what will happen and also probably useful for insurance. Yes.
Yeah, for sure. Yeah, yeah. I mean, insurance is, there is lots of knowledge about insurance in the recovery phase. And insurance companies, they would certainly, they might say, well, if you are combining forecasting with action, then your insurance premium will charge you less, you know? So potentially it's possible perhaps to incentivize people to integrate knowledge. That's a good point, yeah.
Okay, thank you.
There's a question there, I think.
Okay. One question again, maybe.
Thank you, Miss. Professor, can you explain once again how the DM knowledge repository provide information to the meta model to produce output in slide number 4? Thank you.
This is slide number 4. So the question is, how do we retrieve knowledge from the repository? To the blue box, okay. So the yellow box, if you like, you can think of the yellow box, the way we've implemented it, we've used relational database, MySQL. So the blue box is more of a conceptual box, if you like. So it's not really a software component per se. I would think of the blue box here as the database design. So if you take, I think Siti did this diagram a while ago. So she used MS Access, Microsoft Access. Dedi ended up using, as I said, MySQL. So you can think of this box as where the knowledge, if you want to think of it technically, as a database. And one of the things that we learned about also this taking meta modeling as a basis for storing knowledge into a relational database, that the OMG level, remember those 3 levels, there's M2, M1, M0, maps nicely to relational database systems, where if you take the M0, at M2, you are talking about the database design. If you take M0, then you are talking about specific records, and the records design, the name of the record. In a relational database, you have the name of the record. And at M0, you have the specific value. So if you have a meta model generated using OMG framework, M2, M1, M0, you can easily take that and design a database around it. So the meta model, the top layer, the language, would become the basis of the relational database design. And then when you populate the meta model, you are actually populating a relational database. So the M0 knowledge goes in the values of the records. The M1 knowledge goes for the names of the records. That's a really good question. Yeah. So that's how you would implement it. And now, how would you retrieve it later using agent-oriented? That's an excellent question. You can formulate SQL queries using agent terms. And that's what Dedi did. And he had SQL queries both ways going, SQL queries for populating the repository, because SQL queries, you can write things into and he had SQL queries for retrieving. And the SQL queries were designed using agent-oriented meta model. Very good question. Yeah. Now you can go off and do it. But we've never actually published how to do it. So that's a really nice. It should be published. I think it should be written, because people would look at it and say, "How do I do it?" Which is the answer. Yeah.
Okay, thank you, Professor Ghasan Budeoun. It's the good answer with the great questions. Maybe there's was last questions, and I will read the conclusion of today's presentations. Thank you, Professor Budeoun, for explaining about agent-based knowledge analysis. From your presentation, we understand the good information system help the organization make better decision, and we learn the good information system help the people find the right information quickly and solve the problem. Your method knowledge unification language synthesis show how to use people roles and situation to provide useful information at the right time. The method help with the many areas like online teaching, farming, and disaster management. It is the glad to see how teamwork between government, business, and research make the sharing knowledge easier and more useful. Thank you again for sharing your knowledge with us. Yeah, okay. Thank you for participants in the Zooms. And that's all for today's session. I'm from Faculty of Science and Technology, Mayang, from Universitas Terbuka. I want to thank you from Professor Budeoun for sharing his time and knowledge. And thanks to everyone who joins and asks the question. We hope to see you at the next event. Now, back to MC, Miss Madidia. The time is yours.
Thank you. Thank you, Mrs. Mayang and Professor Ghasan, for sharing insightful knowledges about current information technology and agent-based knowledge analysis. Well, what an enlightening information that we have here by joining the visiting lecture in 2024. Thank you, Mrs. Mayang, for guiding us through the visiting lecture session. Also, we would like to thank our wonderful speaker, Professor Ghasan. As a token of appreciation to our speaker for taking his time here and share precious knowledges about current information technology, we will give certificate and a little memorable merchandise from Universitas Terbuka that will be delivered by Dean of Faculty of Science and Technology. It is an honor for us to invite Dr. Nurma to give certificate for our speaker, Professor Ghasan Budeoun. Dr. Nurma, if you may come here forward. Please stand here, Professor Ghasan. One more time, smile. Okay, thank you. And one more, the merchandise from Universitas Terbuka. Now please look at the camera, smile. Okay, thank you. Please stay here for a little while. Yeah. We would like to invite head of study programs, lecturers, and all participants who joining us either here or virtually to have a photo session with us. For those participants joining us virtually using Zoom, please open your camera. Now, please, the head of study programs, lecturers, and all participants, please come forward. We will do photo session. All participants, please open your camera. Maybe we can make 2 or 3 rows so everyone can be seen on the screen. Okay. Oh, saya juga. Okay, please smile. I will count down now. 3, 2, 1. The last pose maybe with the UT pose. U on the right hand, T on the left hand. Yeah. Okay, thank you. You may take back to your seats. Okay, thank you, everyone. Ladies and gentlemen, we have reached the end of today's event. On behalf of the committee and the whole faculty, especially Information System Study Program, we would like to extend our gratitude for the speaker and all participants for your contribution on this event. And also, I would like to remind all of the participants of today's event to fill the attendance form by clicking the link already shared by the committee. We hope today's event become a great experience for you to share knowledges, experiences, and inspirations. Hope to see you again on the next visiting lecture. My name is Dia. Thank you and have a good day. See you on the next visiting lecture session.